Hello, my name is Ardi and we are going to solve problem 27. So the question is calculate the current in the circuit of figure 2651. So this is the figure. And show that the sum of all the voltages change around the circuit is 0. Okay, we have a 9-volt battery here, and let's label which one is the positive terminal and which one is the negative terminal. The long one is a positive terminal, so I will label this as plus. And then the short one is a negative terminal, so I will label this as minus. And then remember, the current is flowing from the positive side of the battery, and then that goes into the negative side of the battery. So the current will flow like this. So let's name this current as I, and then it will continue to this branch here. So I will have I, and it also continues here. And then finally, it loops back into the battery. So this is the current that we are looking for. However, here we can remember that this resistor 9.5 volt and then 16 ohm, I mean 9.5 ohm, and then this 16 ohm, and then the internal resistance of the battery, which is 2 ohm, all connected in series. So I will have all the resistor is connected in series. So we can replace them with a single resistor, which is, let's call them the resistor of the series, which is just their value added up together. So I will have 9.5 and then plus 16 and then plus 2 ohm here. So I will have plus 2 here. 16 plus 2 is 18, and then 18 plus 9.5 is 27.5. So I will have 27.5, and the unit is ohm. Okay, so we can redraw the circuit here with a single battery and a single resistance. So we will have a 9-volt battery here, and then a single resistance here. And this is the positive side of the battery, this is the negative side, and this is the R series, which is 27.5 ohm. And this is the current that passed through it. We name that as I. However, because we have a single battery and a single resistor, we can just use Ohm's law to calculate this current. So we can use Ohm's law now. So let's do exactly that. Ohm's law, which is the current is equal to the voltage divided by the resistance. What the voltage of what? The voltage of the battery. And then the resistance of what? The series resistance, right? So I'll have a series like this. The voltage of the battery is 9 volt, and then the series replacement of the resistor is 27.5. So I will have the current. I think this will be the job of a calculator here. So we will have 9 divided by 27.5. That will be 0.327. 0.327, and the unit here will be ampere. Okay, and so we get the first part of the question done. So this is the answer here. And the second one, show that the sum of all voltage change around the circuit is 0. Okay, for this we need to see the original circuit. So we need to see this one, right? Because they are equivalent. And remember here, di is the same in all of them, which is this value here. Okay, now let's label the voltage in the resistor with their plus and minus polarity. So remember, the I is flowing from positive side to negative side. So I will have the polarity like this, plus and minus. And this one also like that. So I will have plus and then minus. And then for this one, I also have plus and minus here because the current flowing from positive to negative in a resistance, right? Okay, so now let's calculate the sum. So the sum of all voltage change. Okay, now let's start from this battery here. Here the current is flowing like this, right? And then the current is flowing from the negative polarity to positive polarity of the battery. So I will have negative sign here. So I will have minus, and then the value of the battery is 9 volts. So the voltage is 9. And then plus, why plus? Because the current now entering from the positive side to negative side. So plus, then I will have 9.5 multiplied by the current. Why? Because resistance time current is equal to voltage. So I will have 9.5 I, and then plus I will have 16 I because of the same logic, right? Plus because this is flowing from positive to negative, and the value of the resistance is 16, and because we need the voltage, we multiply it by the current. And lastly, we have this 2 ohm resistor, so I will have plus 2I. Okay, and then all of that will equal to what? Which is the one that we are looking for, right? So maybe let's do it like this, minus 9, and then all of this will equal to 27.5I, right? And then I will have minus 9 plus 27.5 multiplied by 0.327. Okay, and so I will have minus 9 and then plus, maybe that is the job of our calculator here. So I will have 27.5 times 0.327. That should be 8.99, or this is because the rounding error, so I will have 9 here. So I will have, this will be 0. So the sum of the voltage is equal to 0, which is exactly what the Kirchhoff loop rule says. Okay, and then that's all for this problem. Thank you for watching. See you in the next video. Bye-bye.